Welcome back to this video. This is Unzadani. So we are going to proceed with the glycerides in details. So glycerides are just ester compounds of glycerol and fatty acids. So what we mean here is that the carboxyl group, the hydroxyl group of glycerol. So here we are just going to say each hydroxyl group of glycerol reacts with a carboxyl group of a fat acid. So when they react, the hydroxyl group of a glycerol, each hydroxyl group of the glycerol with the carboxyl group of a fat acid, that's when we have glycerides. Glyceride. So this is actually a condensation reaction, since water released during this reaction. So the fat acids are named according to the number of fat acids that they have. So we have, if we have one fat acid, this is equal to monoglyceride. Then if we have two, so this one is a diglyceride, and if you have three, that's a triglyceride. So let's look at an example of how we form a glycerides from the fat acid and glycerol. So let's try to write the glycerol here. So we have a glycerol, H here, H here, H, another H, another H here, another H. This is the glycerol. So this is glycerol, then plus So we have fatty acids here. We have different three fat acids because each of the fat acid is going to react with each of the hydroxyl groups here. Let me just draw these groups here where the fat acids will be reacting from. So we have this fat acid here. So we've written them in short form. So we have this one, then H, that one. So this means that this one has got so this one has got 16 carbons and 32 hydrogens. So we have another one, HO, here. Then we have C 17, then we have H 33. So this means that this one has got 17, has got 18 carbons, then it has got 34 hydrogens, just like this one. So not supposed to be a 31 here. So here we have 32 hydrogen. Yeah. Then we have the last one, we have HO. So we have C17, of H81. So these here, they are named here. So let me just use in red. So we have palmitic acid. Let me write it properly. So we have palmitic acid. Then in brackets here we have this configuration, the notation. So we have 16 carbons. We have 16 carbons, then 0 double bonds. That's how you write it here. Then we have oleic acid, and the notation will be 18, meaning 18 number of carbons. Then we have 1N, meaning one double bond at position 9. Then we also have linoleic acid. So for this one we have 18, then we have 2N, meaning we have two double bonds, 6. So this 6 just means it belongs to the group of omega fat acids. So it has omega fat acids. Then for esterification, now we have this one. So we call this esterification. So there is a release of water. Water is released in the process. So the structure that is formed now, we have, let me just use a green. So we have C, have another C here, then we have another C here. So we have this one, this one. You have this one here of carbon, of carbon, carbon here. So you have C15, we have H31 then. Also this one. So we have H2 here. Here we have one H2 here. So we have C17 here. C17 H33. We have C17 H31 here. So this is a triglyceride. Since we said diffy, it has got 3 fat acids. So we have a triglyceride. So this is a triglyceride. So there is a release of water molecules, you can see here. This is the water molecule. So this is a condensation reaction. So the long chains of hydrocarbons of the fat acids, they form the tail. Like this will be the tail. Long chain of hydrocarbon form the tail. So this is actually what makes the fat acids insoluble. So tail. So tail, which is hydrophobic. Hydrophobic tail. So even this one, also this one. So these are hydrophobic tails. So these triglycerides are actually common in nature. Common lipids, or commonest actually. Let's say the superlative commonest lipids in nature. So these are the commonest lipids in nature, and they are classified as fats. If they are solid at room temperature or oils, so solid as fats, then liquid they called oils. So make sure you understand what we mean here. So let's go to the next lipid, which is the phospholipid. So phospholipid. So what is a phospholipid? So phospholipid is just a modified form of a triglyceride. So where one fat acid gets replaced biphosphate group. To a nitrogen containing molecule. So these phospholipids, they form micelles or liposomes in water. They form micelles or liposomes in water. So because of the interactions between fat acids chains, so fat acid chains, especially the tails, which are hydrophobic. So these they cluster together, cluster together inwards away from water, while the phosphate group is able to interact with water. So the first fat group is the one which we call the head. Into contact with the water. So the phospholipids are actually found in cell membranes. They are found in cell membrane where they form phospholipid bilayer. They form a phospholipid bilayer, which is actually important for the function of the cell membrane. So let's try to write the structure of the phospholipid so that we can see it visually, not just talking about it. So the structure will be like this. something like this. Then we have this, the tail here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we have the tail with the 17 carbons. Then we have how many hydrogens? So 17. So we have 34 hydrogens. So this one will just be a straight structure. It will just be straight. But here we have this one. This one will have a double bond. So this one will have a double bond. So let me just write 1, 2, 3, 4, 5, 6, 7. So we have seven hydrogens, then 7 carbons, I mean. Then how many hydrogens? One. So we have 14 hydrogens. Then we have, so here where it joins, where it joins with the last carbon, like we have a double bond here, so it curves here. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 carbons. Then we have 19 hydrogens here. So these are non-polar fats here. Let me just see. Write it in red. I mean the non-polar tails. So these are non-polar tails. Then we have this one where there is a phospholipid being attached. So we have this carbon being attached to a hydrogen here, and another hydrogen down. Then here it is attached to oxygen. Then this oxygen is attached to a phosphate. Again, this phosphate is attached to oxygen. Like this. Hydrogen here, another hydrogen, another carbon, I mean. Then for hydrogen, this carbon is attached to a nitrogen. We have CH3 here, over CH3. Let me write properly here. So we have a negative here, and here we have a positive. So this is the phosphate group here. Let me use a red color here. Phosphate group. So this is the phosphate group that we're talking about. So this whole thing here, this is the head, polar head. Thank you for watching the video. In the next one, we are going to conclude with the lipids. Thank you for watching the video. Make sure you subscribe to the channel.